Okay, so it's 10 o'clock. Why don't we get started, everyone? My name is Jeff Rodell. I'm with Long Building Technologies, and this is your Thursday morning coffee break. Thanks for coming out this morning. Today, I have my co-host with me, Steve Morrell. He's with Critical Room Control. We're going to kind of focus on the room pressure monitoring system inside a critical environment. But Steve, if you could real quick, just kind of give a brief overview of what CRC offers.
Yeah, so CRC, we've been a company started back in 2004. We started as the first manufacturer of a touchscreen pressure monitor. And then since then, we've evolved into developing lab control air valves that actually measure airflow, and then developing the controllers for them and integrating a pressure monitor and laboratory room controller into one, providing solutions for both healthcare and laboratory environments.
Okay, so CRC offers an entire solution for your critical rooms, but today I think we're just going to focus more on that room pressure monitoring and that whole environmental envelope inside a critical room. So let's kind of touch base on what our main two types of rooms are. You have your positive pressure rooms and your negative pressure rooms. Positive pressure room, a great example there is going to be an OR, some sort of operating room, a clean room, sterile room, or protective isolation room. Negative room is going to be your laboratories, infectious isolation rooms, something along those lines. Really, you have two different things going on there. With the positive pressure room, that's something that you're trying to keep out any bacteria, germs, anything that's going to work its way into that room. I think of a operating room with someone on the table, they're getting their knee worked on, they're cut open. The last thing you want is something to infiltrate that room and potentially get that patient sick. So that's why you have that positive pressure. Conversely, on the other side, you have the negative pressure. Laboratory is a great example there. There's a lot of things going on inside that lab. You have chemicals, fumes, that type of thing that you don't want to escape out into the hallway or any other part of the building for that matter, and possibly, get someone sick that's walking by that lab. So those are kind of your two situations, positive and negative pressure rooms. Steve, do you think you can touch base on how we monitor the pressure within those rooms?
Looking at the standards, OSHPD kind of has their standards saying, hey, you need to have visual and audible alarms at these spaces. And then ASHRAE standard 170 talks about a visual indication. And there's a couple ways that can be achieved. Looking at how CRC kind of does it, we have the example on the screen of a full entire touch screen that gives you easy to understand green is good, red is bad. And another option, simplified version, would be like a ball on the wall, which is simply just a ping pong ball based on the location of that. If it's outside the room, then it's a positively pressured room. If the ball is inside the room, then it's negatively pressured.
Okay, so we have some options here. The CRC offering with a nice green screen, and then it looks like we have that ball on the wall. I mean, why not just keep it simple? Keep just the ball on the wall. Why go to the extent CRC does?
So the ball on the wall works, and it achieves what they want of checking that box of that visual indication. Where CRC came into play is we talked to a lot of the nurses and the people that actually utilize these spaces, and that ball on the wall only helps that nursing staff when they're looking at it. It doesn't have any audible alarm. It doesn't give you any other indications if the room is occupied or unoccupied, if it's achieving the right air change rate. And it only, again, really emphasizes the pressurization when you look at it. If I'm not looking at it, the room could go unoccupied or could lose pressurization, and I would have no idea that this room is unsafe. So it really doesn't achieve a lot of the other valuable pieces that matter to the staff using these spaces.
Okay, so instead of just checking a box, we want to have more information. So I think this is a great example here. This is a real world application. The end user had this Cetra system installed in their facility. You do see the green light there indicating that the room is at normal pressure. It does give you the pressure reading on that small screen. But when you put it side by side with the critical room controller, it's a night and day difference. You see, you have your green thumbnails there that clearly indicate the room is occupied, if it's safe to enter. But not only are you receiving that pressure reading, you're looking at it from an entire environmental envelope. You have that temperature reading. You don't want to have your OR spike in temperature or decrease in temperature all of a sudden. You have your humidity ratings as well. We all know that too much moisture inside a room could obviously damage the equipment that's inside there. You do get your pressure reading. but also you're seeing your air changes. You know how often that air is circulating in and out of the room, and if you are getting that clean air to the room that you need. So we know that we have these nice fancy screens. Obviously, we need to make sure that the information getting to those screens is accurate. Steve, can you kind of touch base on how CRC achieves this?
Looking back, and when we decided to develop a touchscreen pressure monitor, it was really the first one in the market back in 2004, and people didn't trust sensors, or they didn't trust the data they were getting. So that's, again, where the ball on the wall comes into play. It's simple, it's tried and true, that these sensors, looking at them, there were two types back in the day. You had thermal anemometers that measured the velocity of air passing over a hot wire, and these were extremely accurate, but they required the clean air going over that sensor to be accurate. And in these environments that are often have dust, dirt, lint, these sensors would get clogged up and would get dirty and then foul over time and required constant maintenance. So when looking at that, we didn't want to have something that was constantly having to be maintained. So we looked at a diaphragm type sensor. The diaphragm sensors didn't have any air passing through them, meaning they were dead-ended. These sensors, though, the wafer inside that deflected based on the pressurization were made out of metal or stainless steel. And what happened to those, over time, that metal changes shape as you put pressure on it. So they often had compounding drift and had to be re-zeroed, or some promote auto-zeroing nowadays. And that wasn't really something we wanted to promote because, again, now the longevity of that sensor comes into question as you constantly have to auto-zero or re-zero that type of sensor. So we actually had to go out of the HVAC industry, and we found an industrial pressure transducer made by Ashcroft. And what they did was a dead-ended sensor that we liked, but instead of using a metal wafer, they used a silicon-based wafer. That silicon-based wafer now is a better elastomer, near perfect, and will go back to its same original position day over day, month over month, year over year. And we've had over 15 years, we've had a great success with these. Not needing recalibration and being consistent and accurate over their lifespan.
So it sounds like to me this particular transducer, you do not need to recalibrate it. You're not going in and zeroing it out. I mean, what type of failure rate do you see on these? Are they going to last a while? Do you have to replace them often?
With the sensor, Ashcroft actually publishes 55 years for their mean time between failure. And I've been at CRC 5 years, and we've been doing pressure monitoring for 15 plus years. And I would say we've had less than 10 returned in the lifespan. And normally it's not because it's failed, it's because somebody ran 110 volts into it or somebody dropped it. So I would bet my life on this sensor that it works when it's powered up and installed properly.
This sensor is probably going to last longer than the facility would. So I don't think that's much of a concern there. Okay, so now that we understand, kind of the heart of the system itself, where do you put these displays? I mean, is it something that you just have on the outside of the room so a nurse can walk by and clearly see that information? Or is it something that you would also want to see on the inside of the room? Steve, you want to kind of touch base on where you would recommend having these displays?
So typically, I mean, this is a prime example of how an engineer or would lay out and design kind of a critical environment. This is actually an isolation room with an ante-room, and every door into these pressurized spaces has some kind of monitor. And that's actually the kind of standard that is followed is if you're going to have a pressurized space, you need some kind of indication at that door so that before you even enter the room, you know if it's safe or not to enter. What CRC is looking for is now once I'm actually in that room, how do I ensure that it is still safe? Again, just like that ball on the wall, it was good when I was looking at it, but if I'm not looking at it, how do I know? I entered the room and it was good when I entered the room, but how do I know that it's maintaining safety while I'm in that room and I'm not in a contaminated room? So looking at being able to put a display inside the room, so while I'm there operating, doing whatever chemistry or labs or doing my operation, I know that it's maintaining that safety throughout the use of the room.
And then, correct me if I'm wrong, but I know, especially in the operating rooms, that type of information needs to be tracked and monitored throughout the procedure by a nurse or someone within the room. That way, if all of a sudden they lose pressure, temperature swings, any humidity spikes, that's all goes into a log that the hospital itself will keep track of. Just in case something does happen to that patient, they have that information. I mean, really, it's a good way for them to avoid any type of lawsuit from the patient potentially. Okay, so we know where they're going, how many we should have. As far as the installation process, it's not overly complicated. I know, Steve, you've worked on a bunch of these over your career here. Can you go through with the group and explain how these are installed and go through how easy it is to install these?
So there's a couple ways that pressure monitors can get installed. One way, and the original way a lot of people did, was mounting everything right in the wall. Doing your electronics, doing your power running to your wall, running the pneumatic tubing, having your transducer right there in the wall. There is a benefit to that. It's easy to access because it's right there on the wall, and I can access any improper wiring or that kind of stuff that could be an issue with the transducer or the pressure monitor. What CRC found is when you're looking at healthcare and you have a lot of these facilities, you don't have a lot of wall space. You often have piping, you have pneumatic tubing, you have gas lines all going in the wall. You don't have a lot of depth in your wall to do a triple gang box and try to fit all these electronics. And contractors often hated having to run pneumatic tubing down a wall and trying to bend it and kink it to get it into that triple gang box, and also running power down a wall and all these other devices that they had to do. So the way CRC looks at it is we put our box up above the ceiling that has our controller mounted in it. It has our DPT mounted in it, and then everything gets run to there. And then our display on the wall, all you need to run is a Cat5 cable down to your display, and you really have up to 200 feet to run that Cat5 cable to wherever you want that display mounted, which allows a lot of flexibility on where you put your controller and keep that pneumatic tubing easily run to really figure out your system.
Okay. So, I mean, a simple Cat5 cable to the display, that obviously is easy. Are these a one-to-one application? Is it one controller per display? Can you operate multiple displays off of that single controller? What are our options there? I mean, how many rooms can you monitor at one time?
So looking at that, we decided that one controller, if I want to do multiple displays in a room, having multiple controllers or multiple pieces of hardware to have to power, have to be backnet connections, and have to give those displays makes it more complicated and increases the cost. So when we developed our controller, the brains of the operation, we allowed it to do up to 4 displays off of one controller. So really you can do an operating room that has 2 doors going into it, your sterile core and your patient core, as well as a display inside the OR. You can easily do from one CRC pressure monitor and really accomplish that whole entire space.
So just to be clear, you can connect 4 screens to the one controller without any issue.
Yep.
Okay. So, I mean, the installation process is easy. The wiring, all of that, it frees up some space for the end user itself. The screen is really the nice part of this. So I would like to kind of touch base on this again and go back to how this is more than just a ball in the wall. I mean, you're getting a lot of information here. It's very customizable. As you can see on the screen here, you have your green light indication. Is the room safe? Is it occupied? Can I enter? It's easy to see. It's clean. It's a 7-inch display. But again, we're not just looking at this from a pressure standpoint. We really want to focus and emphasize the fact that this is an environmental reading of the conditions inside the room. So yes, you're getting your pressure reading, but you can see at the bottom there, you're getting your room temperatures, your humidity readings, again, pressure, but also those air changes. So you know that the room is safe, you're getting that clean air, everything's the way it should be. But it's also customizable for the end user. They can change this thing up any way that they want. It's very simple. It's a touchscreen display. We all have our smartphones. We're used to swiping left, right, up, and down. So, I mean, this is something that really anyone can use, and it doesn't take a lot of effort to set up at the end of the day. It's a clean, safe, easy, effective way to do things while achieving all the goals that you have to inside a critical environment room. So don't just think of a ball on the wall. Try to go beyond that and try to imagine this screen and how much information this truly does provide for you. So with that said, that is the conclusion of the presentation today. I would like to thank everyone for coming out and taking the time. Hopefully this sparked some questions inside your head. If you do come up with questions, please contact your local Long representative. We would love to provide more information. Again, this is just the monitoring portion of what CRC does. They do offer a complete control solution inside the room with the valves. So feel free, reach out, let us know if we can answer any questions for you. I would like to briefly introduce next week's topic. Mr. Doug Kling is going to review Q-Pack EC fan arrays. So I look forward to that. Hope everyone can come out next week on Thursday at 10 o'clock. And thank you very much for your time, and enjoy your coffee.